they'll start to slow down their growth and then hug the asymptote of 600. This is what you guys are learning. So environmental sciences teaches you what it is. BC calculus, we actually learn is solve it. Okay? So BC calculus is actually solves this stuff, and environmental science just tells you what it is. Okay? So it's called logistic growth in BC. And they learn it during this chapter. So I just want to show you this picture of what it means. So what happens is populations grow, and when they hit halfway, then they still grow. Their growth slows. That's why our inflection point we've talked about, concave down. So we just go like this. So I want you guys to see that in the picture. So what happens is the growth goes like this. Once you hit about half of 600, once we hit the halfway, you'll start to see it. If you guys see a flat line in anything, treat it like it's an asymptote. Anytime you guys see that in a slope field, that's an asymptote. Oh, okay. So we're going to hug our asymptote. And that's what your drawing would look like. Those are asymptotes in the graph. And that's why this is logistic growth, or carrying capacity. Okay? We call it logistic growth. Right? So what if we started with 800 and only 600 survive? What's going to happen to these cattle? They're going to go like this. They're going to die off. We put too many there. It's not nice. All right? They're going to start to die down. And if we did the math, you'd find out in BC, actually, we do the math and I show them, they start to see, and the population's going to dwindle down, and we're going to hug the asymptote. You'd see it. We'll do the math next year, and you'll see, oh my God, they went down to 602, 600, 601. They eventually die down. Sure, there'll be a time in real life where maybe it dropped to 598, because of some invasion of something that came and attacked them or something, or some disease and stuff. But typically, they're going to just drop to the asymptote. That's what carrying capacity was trying to teach you, right? Environmental science. All right, so there's the math behind it. That's what it looks like. Okay. All right, so just want you guys to see what we're drawing. All right, so do you guys see this dot? First time I did one of these, I did it wrong. So AP, I was trying to learn this. When slope fields came about, when I was in school, back in the 1900s, slope fields were not around. They were non-existent. So when I've taught, after about probably 10 years, they sent us a memo going, you have to teach your students slope fields. Never heard of it. So I show up to one of those Saturday trainings, that they have College Board has, all day training, and they taught us what a slope field was. Many people showed up because most people didn't know what a slope field was. And I think I got 70 to 80% knowledge from that meeting, one day. And then I thought I knew it better than 78%. Then I realized, then later, after the next year, I go, I finally got it. I had to study a little bit more. So first time, if you're ever on the asymptote, if your dot's on there, you just stay on there. So if they start you on there, it's not an asymptote, that's just your graph. So I just want to show you guys that. So if your line is on there, that's your graph. So go ahead and highlight that. So it's not an asymptote if you're on there, so your graph would actually be that. So they actually, one of the AP questions, put the dot in there, and I thought, I don't think we stay on. Is it an asymptote? And I'm on there, and I kind of went like this. So I would have lost a point that year, not good, because I didn't understand that I stayed on it. All right, so you have to stay on it. All right, over here, this one's kind of a waste of time. You can see that it's just going like this. This one's kind of pointless. All right, so if I was redoing this, I'd wipe that out. All right, no, it's just that one. All right, what are you guys on the right with? This one's a good one to talk about. What do you think is going on the right? So we have to draw on the right. So clearly if I went this way, you can just see the arrows. Look, it's saying go this way, this one's go up. Okay, I can see that. But what about going this direction? So if I were to follow the arrows, so I'm going to head this way, they're saying go this way. What does this tell me to do? What do you guys see? If I start heading this way, what are these lines starting to tell me which way to go? So you're seeing this, are you seeing a full turn up? Does it show me to turn up? What does this do right here? It says the flatten out. So you're correct with the turn up. It has the flatten out here. You guys see this flat line right there? You can't see this one because it's on the x-axis. That's what makes this hard right here. But as you go, and you get to here, it's saying, hey, flatten out, and then you have an asymptote. So this is like, start heading this way. The arrows are like, go this way. And then the arrows are like, flatten out. And then then here's like, you got an asymptote here, so you're like, oh, this one's a little harder one, but that one's not as easy to follow. But you just got to follow the arrows. But can you see it on the right? So you see how it's kind of making the turn? No? Ish. It takes practice.